Hello, friends, and welcome back. This is actually the course which I felt I have to create because since I started this channel, I have created so many videos about the Docker and containerize, how you can set up your local environment, a development environment using the different Docker images, whether it's a database or different kind of a tools like a Terraform or Jenkins or MySQL or NoSQL databases like MongoDB, Couchbase, any kind of a database, how efficiently you can set up using the Docker. So that's the reason I thought to let's have an introduction on the Docker, about the Docker course and how we can understand what exactly the containerized platform, because Docker is one of the containerized platform. There are other containerized platform as well, such as Rocket or Podman. So let's see. So in this course, we will try to explore and understand few concepts like introduction of a Docker container, how we can install the Docker on different OS like Windows, Mac, Linux. Of course, we'll go through the documentation. I have very tight hand on the presentation, but I'll try to explain things with the help of official documentation. So whoever is aware, whoever has gone through this video, they will find the official documentation is useful, and they can also explore more advanced concept about the Docker or any kind of a things. Then we will create one small Python application, and we'll just run that as a Docker container. Then we'll explore, try to understand few concepts like registry, repository, what is exactly the tag, what exactly the meaning of the name, image or Docker image name, what are the different tags we can have. Then we'll just play with, try to pull some images, try to push images and containerize. And we'll understand what exactly the Docker architecture is. What are the different components like Docker client, Docker engine, Docker desktop application, and will then you will, of course, you will come to understand that why is Docker popular, and then we'll play with the different images. How what are the different environment variables you can set, and how can you can create a Docker file. Then we'll play with the containers with the different arguments, how we can create the containers, run the containers, how we can go inside the container and execute the different commands. Then we'll try to understand few commands like stats and system, how we can identify the process and everything. Then we'll just, there is one more blog which I have written, which is about how you can reverse that, because everyone is talking about creating container from the image, which is like a straightforward or one way. If let's say you accidentally deleted image, but your container is there, so how you can reverse that and create the image from the container. So these are the few concepts I'll try to explain with this course. This course is, design, in a, when I'm thinking this is for developer who just need to know what exactly the Docker and how to use it. We don't need to understand like advanced concept unless and until you have to go and dig deeper and debug something. If you understand what is the image, how to create the image, how to what is the way to build and how to push to registry, what are those things like a core concept, this course is for you. If you're looking for like a something like a DevOps kind of things, the context, then this course is not. This is like a beginner course to understand few concepts. So let's first understand what exactly the Docker is. Okay. And if you look here, this is the Docker website, which is official website. If you look, developers love Docker and business trust it. The tag itself saying pretty much things, right? It's like a developer loves and also business, because the operation headache is gone, most of the things, and you cannot say now that this is working on my local but this is not working somewhere else. If you try to relate the container image, right, the actual physical container where we are putting the different kind of things in that container. Okay, so always if you'll see, right, on the ships or on your containers, you will find on the transport container you can put anything in that container, and that container you can move anywhere. Okay, from one location to another location, it will not change the state. Container, the Docker file is itself the consist of the layers, which are the immutable layers. What it means, I'll try to show you when we'll look for the Docker file, how to create that Docker. So what exactly the containers, and before the container what is the problem, because technology is the like a solution to address specific problem. If you have the problem, then only we'll have the solution. So container is, and the VMs are similar kind of a things, is like a isolate an application, its dependencies like a self-contained, and container is a self-contained unit. You can take it from anywhere and run in it, it will run. You can relate this with your not exactly map, but you can relate this with your Java code. Write once and run anywhere. Write once Docker file and you can run anywhere, whether it's the cloud, your on premises, or anything. Wherever you will Docker run environment available, there you can run the Docker container. Okay, so moreover, containers, like a main difference between container and VM is their their main difference is that their physical nature. If you look, we have the container which is self-contained, like you have Tomcat, Java, and their underlying OS. Same for PHP, same for any other, let's say Python application or anything. And underlying you have the kernel and the Docker, which is like a we need a Docker runtime and all. And Docker is more optimized, and specifically it's tuned to the Linux kernel, because Docker is nothing but like it's combination of a different kind of a Linux systems only. So long back I have wrote this blog which is about demystify the Docker container technology and why Docker. So if you look here, right, you will find out the difference by yourself. What exactly mean by the Docker? Okay, so you just need to understand different methods, right? How we can virtualization is there, like emulation or simulator. If you're aware about the mobile application development, you will understand this simulation and creating the Android EVD or iOS device. There is another one is like a hardware assisted virtualization, like a Intel virtualization technology or para virtualization, which is kind of a similar thing. Then FreeBSD jails, and then again the last but not least, container based virtualization. So it's kind of a virtualization only, but it's they have very well used the Linux technologies to make it like a isolation process, and each process has their own file systems and how they achieve. There is the things, if you look virtual machine, you have the infrastructure underlying, then you have the host system, then you have hypervisor layer, which is like a software layer which is required, which is must, and then on top of that you can create your own virtual machine system. So you have to share those resources, again underlying OS, then that specific OS for that VM. So the with the Docker, you no need to worry about this underlying OS and hypervisor layer. I mean hypervisor layer. So if this is removed, it's optimized one. Okay. So that's the trick here in the virtualization. Okay. So when we say the virtual Docker containerized virtualization, it's like a operating system level virtualization. It's not the virtualization on top of your hardware. Actually, it's actually providing you abstraction on your infrastructure, but more on it is managed at the operating system level. Okay. There are examples like Alexi and Live container. Container and Docker is not a new technology, as I have mentioned, which is with the limited resource. Okay, so let's see some Linux stack and how Docker is used, how the Docker is clubbed together and provided the abstraction so that end user can just focus on defining the Docker file and create the container. Underlying what exactly is, so there are few Linux technologies. Those are reused, like a ulimit that commands to lets you set the pre-process limit, like the number of opening files. Chroot, like a change the root file system. It is very ancient feature which is inherited by BSD. In the, if you're aware about the Linux ecosystem, you will relate this one. Then you have the CG group, which is like a process group resources limit. Into right, Google engineers contributed this very, I mean, very useful feature. Then the namespaces, which is actually the you can say the core concept and most important to containerize, that helps you to make a processes isolation, define isolation. Union file system to have their own file system, because each container, even though they are on top of the existing underlying OS is there, but they are not inheriting or they are not using that. They are not interfering in the existing file system, or each container has their own file system, their own processes, their own process ID, everything. Even though they are part of a underlying OS, those are isolated. So these are the few things like container runtime, which is a main thing, and it consists of two container runtimes like runc and rocket. Rocket I have mentioned, which is a similar kind of Docker. So these are the things behind the Docker. I hope you can read and go through this one. This is very interesting. If you are from Linux background, you will easily relate. Okay. Then let's move on and how you can set up the or install the Docker on your machine. So I'll just go. This is you can go to the direct to the docker.com and click on the get started. So once you'll click on that one, it will show that the get started with the Docker different option like Docker desktop you can download. Okay, there are different options like Docker for Windows, Docker for Mac. If you're installing for Mac, there are two options. Either you can with the Intel chip and app chip and the Linux system. So you can click on anything. If you just click, it will redirect and ask you to install this machine. So once you download that installer, you can just install as usually with other applications you are installing. So once you install that, it will show like a Docker desktop. Okay. Or you can, it consists of it three things as I have mentioned in my agenda, that it consists of it three things. Okay. Docker client, Docker engine. Docker engine is the core, and Docker desktop is nothing but the UI, how you can access the Docker client. Either you can, if you're more fond towards the UI, then you can go ahead and use the Docker desktop application. If you are more interested in the handling the Docker using the Linux command or CLIs, then go for and use any kind of a terminal or CMD tool. And there is a Docker hub. Okay, so let's first try to if you have installed. So I have installed the Docker on my local machine, and I have launch as well. So I'll just show you what exactly and how it is looking. So this is the Docker desktop app. Okay, once you launch, it will show like this. This is the similar kind of a UI you will get. Then it has few options like home, containers, if any container is running, or if these containers are exited, those are not running, those are stopped. So it is showing like this in a gray. It will show the images what are available in your local. Okay, if you have created any container from this image, so it will show like in use, what is the tag for that image, what is the image ID, when this image is created, and what is the size. So size is varies. Okay, if you see here, I have enabled the minikube and downloaded the minikube image, so that size is around 1 plus GB. But other images are like a less than 300 MB, 400 MB. Okay. Then volumes, if you have attached any volume, let's say you have created any database container, MySQL or anything, and if you want to persist that data, even though your container is exited, that time you can map the volume. And then dev environment, which is a new feature, will not cover as part of this course. So this is about the your Docker desktop. Okay, so we understood what exactly the Docker container. So Docker is nothing but the self-contained the tool. So Docker is a tool, or you can say platform, which is helping you to create the container, which is self-contained build, or you can say, of course, you can say the build, which consists of everything: your application, your related libraries, environment, which is required to run that application. So it's like a bundle pack. You can throw anywhere and run anywhere. So that's the thing. So let's see how we can create the one simple application. We'll first create that application, we'll run it. We'll not try to understand what exactly it means by this, but we'll just try to run that application so that we'll get something. Okay, I have written this blog a couple of days back, so I'll reuse the same thing. Okay, so this is nothing but the same kind of application. So this is about the GitHub actions, but we are more interested in the Docker file. So this is the Docker file which I have created. Okay, in my local. So I have created one simple hello world Flask application. So Flask is nothing but the your lightweight Python framework, which help you to create or define the different REST APIs, and Flask is master, which is helping you in that one. So I'll just will first try to run this application. Okay, if you're aware, whether it's a Python or Java or anything, this Docker file is the same thing. Same thing as in a few contents will be changed inside this Docker file. We'll check that one. So I have defined this or created this application. We'll just try to open this one, okay, with the Visual Studio Code to understand what exactly in this file is. So if you look this, I have imported few packages, okay, a Flask one, and written the one single string like a Flask or Hello World application you can say, and run this app. There is nothing in as such in the code, okay. And then we have the Docker file defined, which is required, okay. So we'll just open this one Docker file just to look what exactly the content here. So it has something like a from Python 3.6, which is nothing but the version of a Python. Then we have mentioned like a Python don't write bytecode one, okay, which is specific to the Python. Then this is also the another environment. So these are the two environment variables, okay. Then we have mentioned to add the code. So when we say the add the code, like a add this slash code to this container, or this image. Then working directory is what? Code. Go to the working directory and run this command. So pip install, who are not the Python developer, this is like a in the requirement files we have mentioned the what are the dependencies. Like if you are Java developer, you may be aware about the Maven or Gradle build tool, or if you're from the Node.js, like package.json file, which is helping you to manage these dependencies. So similar kind of this is the managing dependencies, and with the pip you are installing that dependency, and then finally you are provided the command to run this application Python, and this is the our Python file name. If you're running in your local Python application, how you will run Python on the file name. So same thing we have mentioned here. Okay, so let's we'll go to the this path and we'll try to build the Docker image. Okay, we'll just mention that. Let's go. Okay, and then we'll say Docker. Don't worry about this right now. Okay, what we will do, we'll try to make sure that what are the things available if you didn't get as much. Okay, if you see here I have mentioned that command as well, like Docker build, right? So what we are saying, generate a build from what? So we will mention here, okay, Docker build, right? I have mentioned the same thing here, hyphen t. So we'll provide the Docker image name. You can mention anything, but try to provide the relative name so that it's helpful. So I'll mention flask Docker demo version 1.0. So this is nothing but the tag, colon tag, okay, and dot. Dot means our Docker file, this file is in the current directory. So that's why we have mentioned dot. Or else you can mention the Docker hyphen files and the file path. Okay. So let's build. So if you look here, the logs, you will be able to understand. This is something like a layered file. This is one layer, this is one layer, this is another layer. Every line is a one kind of a layer. Okay. If you look, everyone has a, it checking just the SHA. So the advantage is that let's build first and then we will run it in our local, then we will check. Okay. Meanwhile, I'll just go through the steps. If you look, once we will build, it will generate the image. Then we will run this image. Okay. So what just we need two things, the Docker image name and the tag. Those are the two important things for us to get to know what exactly it is. Okay. So let's check. Think something is not yet done. But most important thing when we say, we'll try to explain this, understand this. And from means it's like a base image. Okay, if you look here, once you over, I have installed the plugin for the Visual Studio Code Docker plugin. So it's helping me set the base image like to use subsequent, because we need something base. Either you can mention the Python, so Python is also using some another base image, or you can provide here the OS name like a Alpine or Unix or the Ubuntu. Okay, what are the base image required for your to run this particular below code. Okay, error from the requirement.txt. Just check what exactly it contains. I have this and then we'll run it. Now you can watch this, the previous log and this one. Okay, because already it builds few things, so it will not again go try to build everything. If you look here, it is started from the run pip install requirement.txt because already previous layers has been built. So if there is no change in the previous layer, Docker will not build. So this way you can optimize. So let's say always whatever what we do, generally we update the code. So Docker will always build the last layer only, whatever the modified. Let's say you have updated few dependencies. Okay, so it will try to build the requirement.txt layer same way. So this is optimized now. Okay, let's run it. Okay, you can look your images as well if it is available. We'll just check whether our image is available or not. Okay, flask docker demo 1.0 tag, this image is available. So we'll run this image. If you look here, we'll use the same command, okay, to run this one. Docker run, and we have mapped this port, image name as docker demo. Let's run it. I hope it will work. Yeah, it's working. Let's go ahead and visit the site. 07. So this is working. Okay, so whatever you have created, this works fine. Now, as per our course, next step will go. So we have created one Docker file. Okay, then we have created one container from that Docker image. Okay, build is nothing but creating image, and run is nothing but creating container. To understand that difference, so container is like a your instance, and build is like a our image is like a your template file or your class definition, like a template. If you understand from the object oriented perspective, you can easily understand this image and the this one. Okay, image and your image is nothing but a template. Okay, and container instance. So from this template you can create as many instances as you want, and you can manage those versions as well. Okay, let's move on. I'll first explain, as we have explained this Docker file. I hope you understood this command and everything, which is if you try to understand, it has more room as well to understand what exactly command means, how you can pass. Command is nothing but how you where mostly you are invoking your application. If you have developed your Java application, then you will mention the Java and what are the jar you wanted to execute this way. Okay, if you have something Java related code, then you will import that build or jar file here, or copy that jar file, or add that jar file here inside the container. Here maybe for Java application you will mention from JDK 9 or JDK 11 or whatever the JDK version you want, or a GRE version instead of JDK. I'll say GRE version, because for Java to run the application you will just need the GRE. Or if you have your organization may have created the custom base image, that is also possible. Okay, another way, if you look here, we are able to see the continuous logging, but you can, once you will press the Control C here, this will get vanish. Okay, it seems my machine got hung, but you can create as many as container from this single image. Okay, so let's move on and understand the next concept, like a Docker concept, like registry, repository, tag, image, and container. So image is nothing but as I have mentioned, this is the template. Okay, if you look, this is the image, and if you look the titles for each one, right? When I fire the command docker images, it is providing me all the images which are available currently in my local. Okay, so it is showing like repository, tag, image ID, created, and size. So I have a one image name. Tag is nothing but like a version or tagging, what kind of a version it is. So generally people have a like a latest version as like a what is the latest version, but you can manage the versions as well. Like if you have open source project, you can say community edition, enterprise edition as a tag name, or management edition, or different versions you can manage at 1.0. So let's build one more time our this image. Okay, the what are the image we have built, right? Currently for our application, we'll try to build the same image again, but with the different tag. Okay, since this is hunk, I'll go through and will try to find the different, open the different and PowerShell. Okay, let me build docker build -t. Okay, then we'll say ask docker demo colon 1.1. Okay, so it will create a new image. Okay, sorry, I missed the dot. I have to provide. If you look, the exactly it is showing docker build requires exactly one argument. One argument as in build an image from the docker file. The docker file was okay. So it will try to build and with the different tag. But if you look here, hence I haven't done any changes in the docker file here. So there is no change in the build. It is just 0.0007. Nothing has been changed. How quickly it is built the image. And once you say docker images, it will show again. This is the 101, the 1.1. You can mention anything in the tag. Okay, let's say you wanted to mention like a this is the free edition. Okay, or this is an enterprise edition. You can mention this one as well. It will build and tag. So tag is like a classifier for your images. Okay, if you look, if I mention again docker images, I'll able to see this one. So this is in my local. Okay, this is in my local machine, and size as well. It will show like a 900 MB. Okay, image ID is like a unique SHA key or hash key to identify that particular image. But if you look for all these things, I have a unique image ID because the content is unique inside this one. Okay, that's why. Let me remove this line, or let me comment out this line first. Okay, and then we'll try to build. Okay, let's say we try to build this. This is the major thing, so we'll mention 3.0 rel. Okay, so it will try to build. Okay, started, then we'll see the change in the image ID because content change. So this hash change. So you can verify with this hash as well what exactly is changed. So you are clear about tag and images. Now we'll move on and try to understand the registry. So registry is nothing but a your uh, kind of a library where you are pushing all the images. So hub.docker.com is one kind of a registry which is on the cloud or central registry where you will able to find out the different images like Ubuntu, Python image, MySQL image, PostgreSQL image, Hello World, MariaDB, different. There are thousands and thousands of images. Few are official, few are unofficial. You can create your account as well and you can run and check. If you ask me, I'll try to log into my account and I'll show you how many images I have pushed. So in my to my account, these two images I have pushed. One is Apache PHP and one is a Flask Docker. If you try to open this image, it will show how you can pull the image. What is the tag? So I have pushed two images with the whenever I have built that tag I have attached that current date and time. So it is showing that tag name, that date and time as a tag name. So from here you can check what exactly the image, what are the tags, what exactly the build is. Okay, automated build. If multiple peoples have collaborated the same image, it will show settings. If you have anything webhook, if you want to enable, if it's you are internally using. So repository So now maybe you're confused between the Docker repository and registry. So registry is nothing but like first we'll try to understand the repository. Okay, repository, if you have the same image but different versions or different tags, then you can say this is the repository. So Flask Docker demo is a one repository which is having this kind of a different tags, and registry where you will have a different type of images, all the type of images in that Docker registry. You can say this as a registry. Okay, so you will find out different registries like a Docker hub. You will find like a AWS has their own registry. Maybe if you have heard about AWS Usecase, they have their own registry. Google Cloud has their own registry. Then Azure has their own registry. So mostly every cloud provider has their own registry. Similarly, you can also have your own registry. You can download this registry in your local from Docker. If you can set up on your database on-premises data center, and you can use your own private registry the way you use like you can use, if you're using JFrog as Artifactory, you can use JFrog registry as well to push your Docker images. So that is the your registry. Okay, so coming back to you understood registry, repository, tag, image, and container. Okay, so let's play something with the Docker images. So there are few commands as well. You can play with those commands. Like if you wanted to remove the image, if you wanted to play with different images, how you can play. So you can simply run Docker image help. Okay, so it will show. If you wanted to see all the images, you can say Docker images. It will show all the images. It will not hide anything. If you wanted to show only image ID, okay, you can check that as well. It will just show the image IDs. You can just take a help of this one only. What are the options available? Okay, so you can play with this one. Okay, or if you're familiar with, if you're using any kind of a Linux system, then you can use the grep command to filter out the images, or you can use the existing filter option as well to filter the images. Let's say you have thousands of images in your local and you wanted to check what are the images and tags available for your particular Python. So you can check that as well. Coming to the Docker container, okay. So that's command is a Docker run. We'll just check what are the options available first. If you look, there are so many options available. So if you look what exactly we did with our Docker run command when we last time executed. Okay, so this command contains what? Docker run -p is nothing but like a port mapping. So this is the outside your system port. You have mapped your container port to system port. Okay, so container port is like your Flask will run on this Python server is enabled on this port, and you wanted to map this port to something else port. So you can mention here anything, any port is available on your local machine, this machine, and this 8070 is your uh, Docker. Inside Docker your Flask is running, and you have mentioned the here the image name and the tag. If you're not mentioned any image name here or tag name here, it will treat that as a lettuce. So default is a lettuce tag. Okay, even if you, let's say in your local you don't have any image available, let me check. Okay, we have different images available, but if you have fire, let's say Docker run, and you don't have, we'll go and check some different image on the Docker hub, some hello something. Oh, okay. So we'll, because when we run, there is an interesting thing. If let's say there is image not available in your local and you are try to run, fire a command Docker run, then it will check first in your local whether the image is available or not. Okay, if it is not available, then it will try to pull that image from your or central registry. Okay, so let me run this one, Docker run. Okay, because this image is not available. So we'll validate two things. This image is not available in my local and we are not providing it. So it will try to pull the, it will check in local. If there is not available, it will try to go and find from the central registry. Right now, by default, the hub.docker.com is the registry available. So it will try to pull from hub.docker.com. But if your enterprise or your organization has their own registry, so you can register or use that URL and it will try to pull from that particular registry. So let's run. If you look here, log unable to find the image. Okay, this one locally. Then it will try and go and find, pull that image from the central registry. And if you look, downloaded newer image. So we'll check Docker images. Here, this image is downloaded. Okay, and if you check what is the process available, so the one or this one is flask docker demo is running. There is no other running. It seems there is some issue with the look. I have used the docker with a command -a as a flag, so that it is showing me the exist what are the container, those are stopped as well, and what is the reason. Okay, so this is stop. So you can explore these things with docker desktop application as well. If you go here and check on the container, so it will show. Once you click here, it will show all the logs. Okay, you can check the logs in command line as well. Let's say docker logs, and you have to either provide the container name, okay, or you can provide the your container ID as well. Okay, I think this is the container. Okay, so it will show the logs. You can use the different commands as well to check the log. If you look here, there is one more. Let's first check the logs, and then we will. If you look here, the container name is different here. Awesome Hypetia, agitated cartwright. Okay, but above, if you look, there is a meaningful name, right? Dev Rabbit, like a Dev PHP MyAdmin, Dev MySQL. So how we can provide that? So if you look our command which we have executed, run command, okay, for our Flask application, find out that available. Okay, let it be. We'll run new one. Docker run. Then you have to provide the name. Let's say Flask dev Flask demo. So this is the container name you have provided. When you mention hyphen d, this will run in a detached mode. Okay, and then you can mention like Flask Docker and demo attack. If you are providing the same container name, then it will not create. If there is the same container already running with the same name, then it will not create the container, it will throw the exception. But hence, we don't have any provided previously in name, so it will create a new container. That's why I have mentioned, right? So container is nothing but your instances, and image is nothing but your template. So this is the one template, Flask Docker demo, and these two instances you have created from the same template, or okay, same image. Here is the meaningful name. So wherever it is required, you can provide the name. If you wanted to expose the multiple port or something, you can mention those by using the -p name. See, and go ahead and check different options, like you can provide the user string like a username or UID, volume list, you can bind or attach any volume as a storage options to your container, because containers are like a stateless. Once you will exit from the container, everything will vanish. So you have to, if you are using, you wanted to store some data or something, then you can use some storage or attach some volume there. Few options like detached mode, CPU can mention, CPU share unit. So there are so many options, but basic one like a port mapping, detached mode, name of the container, those are sufficient to start with. So I hope you have played with the containers and images. Let's go ahead and understand the architecture of a Docker. What are the different components we have in Docker? And we will try to understand what are the useful things as a developer for us. Let's see. Okay. And open the official website. Okay. For you. So if you look here, the Docker platform, what can I use as a Docker for? You can use sudo docker to, okay, build things and as a bundle push. So if you look, we have three components as I have mentioned in your local right now, but like a client where you can run Docker command. If you look here in our terminal, right, we have executed, right? Let's say Docker info, you fire the command. So it will show different information about, okay, what exactly the volume, what is the version, what type of files, what are the different images available, what are the containers, how many containers? 7, but running are 2, stop 5. Total images 13. What is the type of a memory on the current system, installation version, security options it will show, what is the root directory of Docker where Docker is installed, registry as I have mentioned index.docker.io, which is nothing but the hub.docker.com. So this is the registry. So you can change that registry as well by using the set command. By using the set command in your local. Okay, any proxy is available. So it will show all the details. Okay. Or you can, I think version is also command available command. Let's verify. It will show the Docker version, current version, and what is the build hash. Okay. So this is nothing but your client which is running, which is helping you the which is provided you the Docker utility command. That is the Docker client, okay, which is helping you to build the image, pull the image, push the image, run the container, create the container. So that is the Docker. Then we have the Docker host. So when you install Docker in your local you will find these two options like client and Docker host. Okay. So Docker host where always the this daemon container Docker daemon is running, which is continuously watching and creating the container for you. It has created different containers. And if you look, as I have mentioned, while generating the build or creating the images, if base layer is available, it will not try and pull again the same base image. Let's say for Ubuntu, Redis, and another Redis, if you have the same image, Ubuntu as a base image, so it will just download for only one time. After that, it will just reuse this layer again in this below two containers. It will not again and try to pull the same. So that way, this is the optimization, how Docker is achieved. If you look, this is the container. You have created two containers from the same image. You have two Redis container from the same Redis image. And we have registry is nothing but your hub.docker.com, or if you're using any cloud provider or your own organization has their own registry, you can use that one. So Docker daemon is nothing but your Docker daemon, like a, when we say the daemon, it's like a background thread. So it's like a listen to Docker API request always, and Docker objects such as like different Docker objects as I have mentioned, right? Images, containers, networks, volumes. So networks is a bit advanced concept when you have more than one container running and you wanted to make a communication. That you can achieve with the Docker Swarm, or you can use now a famous orchestration tools like Kubernetes or other different tools as available. You can use Docker client is like a primary way how you can interact with the your Docker host. So Docker client will help you. Docker client will use the API to communicate with the Docker host. Then you have Docker desktop, which is like this application. This is the Docker desktop application. And we have explained about the Docker registry, Docker objects as I mentioned, different kinds of objects like image, volume, container, network, and so this is about the our Docker architecture, like a Docker client, Docker engine. Okay, so why Docker is popular? If you look right, um, virtual machine, it's not popular because we need a specific person who has mastery in that virtual machine, creating up a virtual machine, managing this KVM and VM hypervisor layer to understand. It's like a something different. But if you are a developer and if you just need to know or basic things like how to write this text file, that's it. What do you need to understand? What exactly the base thing? Like from Python. This is like nothing but who is a Python developer, he will understand Python version which is required for my application. Few commands like don't byte code and buffered one and what exactly you are mentioned here. Add my code and run this main file and download these dependencies or install these dependencies and run my code. So this any developer can understand. So Docker is provided that abstraction on top of the Linux or your virtualization abstraction, where developer no need to go and find out what exactly going on under the hood unless and until there is a major issue. You can manage with this file. So that's why Docker is so much popular. And it's like an easy step. It's part of your CI/CD. If you just configured once in your CI/CD, you don't need to again go and find out what exactly going on there. You don't need to. So this is the beauty of Docker, and that's why Docker is popular. So we have understood about the Docker images. You can inspect the Docker image as well by using the inspect command. Okay. If you are not familiar with the command, then you can go ahead and check here as well. If you go images, just click on this image, just click on these three dots and inspect. So whatever you have mentioned, it will show everything. But if you look, it's in reverse order. Okay. If you check, first it is showing CMD Python, which is in sequence is a last one. Okay, so it will show like this. Okay, let's see. Let's first inspect the MySQL image file. If you look, it is showing the inspect in the JSON format. So if you are not getting these things, then better you can go ahead and check here, which is providing a very useful and pretty way. It is showing what are exactly things are here in any Docker image. So you can just review if you wanted to review. If you're using any unauthorized file, you can go ahead once pull before creating container. You can just check using these tools. Okay. So this is about our Docker images one more time. Docker containers is like as I have mentioned, we have already played with the few Docker containers you can create. The different containers, check those, and if you see all I have missed all every layer has their own hash key. So that's how Docker understand where it is, where it the new things came, and it will build only that layer. That way next time whenever you build a new image, you will save that time. Let's see and find few different commands about the statistics, stats command, and few like a system commands for Docker. Those are nothing as such, I would say. Okay, to understand and find what is the CPU usage, what are the different things available. So we will just blindly go first find out what are the containers running. Then we'll mention Docker stats. Okay, and the container ID. So it will show what exactly the container ID is, the name, what is the CPU usage currently, what is the memory usage, what is the exactly limit. So right now by default it is taking 8 GB as memory, the whole RAM it is treating as a the max limit. What is the memory usage, then FTIOs, block IOs, and what is the process ID. Because in this container only one you have, so that's why it is showing one as a process ID. Let's see there. So this is useful if you wanted to build any, wanted to understand in your local how much memory what is required before configuring that in your Kubernetes cluster. So you can understand how much CPU cycles you, what exactly minimum memory, let's say 2 GB for your application based on your users. Let's say you have 10 million users and you want to configure, let's say you have autoscaler group 10 containers you can create. So you will get some idea that how much memory you should configure. That way you will. Okay, so let's go ahead and find for our another custom as well. Okay, so that's it. There are few other flags as well, those you can use, and Why I'm always using the help, so that you don't need to buy hard everything. You can reuse this knowledge again. Okay, all if you wanted to put in format, you can mention that pretty using the Go template. Okay, why it is mentioning the Go template? Because Docker is developed in a Golang by Google. Okay, so under the hood technology is that. There are few stats you can use. I don't think so. There is much I have to explain here. It will show most of the things. Even you can combine more than two strings as well. Okay. So what I'll do, I'll just will try to explore more options like Docker stats as demo, and we can say no stream and in the JSON format. So we'll get the data in the JSON. It's the block IO. So this way, let's say if you wanted to develop your own UI for your organization, so you can fire these commands and get the output in the JSON frequently and showcase on your UI. That is also feasible, right? Format. Let's say you don't want the JSON, so you can YML format. So you will get that data. Why I said no stream? Because I don't want to continuously get that. If you wanted to get, you can remove this flag and you will get the continuous output. If you have any change in your container, let's say you get more loads, it will push you the new statistics like new memory usage, new CPU usage. So this is more about the stats command, I would say. Other thing about this one, not much. I think this much is fine. Yeah, if you wanted to just use few, then mention those parameters as well. The table form. There are few commands like you can use like a Docker stop if you wanted to stop the container, or if you wanted to remove. Say I have Docker. Just will go with the first images. Let's say I wanted to remove particular image from my local. Okay, this image. So I'll mention RMI, that is the remove my image, and the tag. So it will remove that particular image. Okay. If you are removing without the tag, then there is no such image because you have multiple tags. Okay. Even you can remove the image using image ID as well. So instead of a tag, I have image ID. Okay. This is deleted. If you look here, it will show other images 1.0, 1.1, not the enterprise and 3.0. So this one I have removed using image ID, and this one I have removed using tag. So how you can stop the container? So let me stop the last demo. So here you can also stop the container using name or container ID as well. So it will take some time to stop the that container. Okay, so this container has stopped. So you can check. So this is not available, but if you use the a flag, then it will show all available. But this is exited. It will show last demo exit. This looks good. So you are clear. Then there are a few commands like docker swarm is there, okay, which is when you create the different commands, or docker system is there, which you can use docker system command to show docker what exactly the docker usage is and few things like system. Okay, sorry, bad to provide the flag. So that's the beauty, right? You will get to know what are the commands even though you forget. Docker system df, so it will show images, active, size, reclaimable, you can how you can reclaim local volumes, build cache, everything it will show. Let's say if there is any events are going on, okay, Docker system so it will show those events as well, or any system information if you want to understand the underlying system what exactly it is, or if you want prune all the unused data, so you can do that as well, and Docker will help. So you can use like a Docker system prune command. So it will purge those data, or you can use Docker system info to get the information. So whatever you are getting through Docker info command directly as well. Okay. So this is like a Docker. There are different commands like Docker copy, Docker images you can use, Docker import, Docker inspect. Even you can, as we have stopped the Docker container, but we haven't killed them. Okay, that's why it is showing in the Docker registry. Sorry, when you providing the -a flag. But let's say I wanted to mention kill last demo, so it's not running. So provide container ID which is running, so it will kill that particular container, and in output you will get that SHA or hash. Okay, what you have logged. We have look docker log as well command. So these are the few commands I would say. There are a few other commands as well which are available in the documentation. You go ahead and check. Apart from the pull and push, you can use push command as well to push your Docker image from your local to let's say your registry. So we'll do that as well. Let me try to build a Docker image. We'll try to build one Docker image from our flask application and manually will push, but when you use CI/CD tool you no need to push manually. So docker build -t flask, sorry, spelling mistake, demo. Sure. This image, then once you will find this image, you need to know, you now need to retag that image because you wanted to push that image to the your center registry. So what we'll do, docker images and docker tag what you wanted to tag flask demo colon 1 to the available niche have docker app. Okay, I'll change the name better. Use the different flag. Use the same name. I'll use my name slash demo test. Now you will see the images. You will find additional image as well, which is this name. Then say docker push, okay, and our image name. Sure. Demo test. Now this will push this image. Okay, requested access to the resources denied. Seems something went wrong. Check. Think I haven't. Wish. Okay, let me just check the documentation. Well, but I have the command. Check one more time that I'm correct or not. I'm the owner. To log in. My account password. Okay, I hope so it will log. Okay, try one more time. Something. Sorry. try. This is my class. Okay, I'm not. Okay, login succeed. Docker. Docker demo. Test, I think. Better I'll copy. Seems it should. Yeah, I think it's working fine. So I forgot to log in. So you need to you had to log in and then you are able to push. So 2, 3. Let's wait for some time and then we will check here. Uh, Registry. It will go. Oh, it's done. Let's verify. Is it available? Yes. Yes. Okay, great. Few seconds ago we have pushed. So this is the image. So think most of the points we have covered. Stats and commands. Commands are so many commands, guys. You can check the official documentation. This is the exercise for you. You go ahead and play, and also let me know in the comment section what is the useful command. But mostly I'm feel useful with this one. Even if you have used any CI/CD tool or GitHub Actions, you can check my blog post as well, which I have mentioned here. I'm pushing this Docker image not manually but using the GitHub action. So you can use try once you have that, you don't need to worry. So let's check the last point, which is the interesting point, which I mentioned as a fun point, like create a image from the running container, and that too I have a written snippet as well. Okay, so if you look here, we know always the straight way, but there is also the way where we can use and come back to the source location. So if you look here, we have mentioned, and then we'll use the new command, okay, which help us to create the image as I have mentioned here. So if you look, docker commit is the command. We'll check there what exactly mean by that. Docker commit help. Okay, we can mention author, changeless, message string, and pause. So let's use docker commit. Okay, mention author as Maheshwar. Okay, and we'll see if any container is running. Let's first identify what's the container is. Now container is running. Docker run docker run one container first. Okay, you can mention you can run this flask demo. Let's run it. I run it in detach mode, so it will show. Okay, with different name. That's fine. Then go use docker commit. We'll mention author name. Then we will mention the container ID, which container you want to create the image. Then we say reverse flask h colon tag is also will mention reverse. You can mention. Seems it is created. Let's see. Bingo. Is it created? So it is created. If you look, reverse flask image, reverse demo. So we'll try to identify what exactly in that one. We'll go here and try to find out. Okay, where is the image? Reverse. Are you? It's available. We'll try to inspect and check whether the content is same or not. If you look, almost all the content is same. From container, you are able to create the, so you are able to do the reverse engineering as well. So that's it, guys. I hope this is useful for you. I'll add the this project code, GitHub link in the description, all the useful articles. I hope this introductory tutorial will be helpful for you and it will add value to you. So go ahead and try. If you face any kind of issue or anything, if you think I need to improve, you mention that in comment. I'm happy to assist you, happy to improve. Please go ahead and use this content. Thank you. Bye bye.